Hello everybody, welcome back to session 2 of our print reading lesson. Let's go over some drawing elements that we're going to find. These are universal elements you're going to see in any drawing. This is going to include lines, dimensions, symbols, and notes. So let's start with lines. Lines are kind of the bread and butter of drawings. Without lines, we could not define the object we're trying to build. Here you see two different types of lines. You see dashed lines and solid lines. You can always count on a solid line being something, a hard edge, something that is existing right there as we're looking at it. A dashed line is going to be something that is going to be implied or hidden, but needs to be referenced. A good example of this on the left here, this arrow is pointing to a dashed line that is going to be the footing of a foundation. It's buried below grade. We can't see it, but we needed to reference it. This dashed line is going to be a wall that's going to sit on top of this foundation. So we need to know the placement of that wall, but that wall doesn't exist necessarily on this specific plane or surface. So it's being drawn in to help us remember where that wall placement is. This dashed line here is an opening that doesn't contain a swinging door or window. It's just a hole punched through a wall. So we can show or indicate that opening in that wall by drawing in dashed lines. We know that it's in that line of the wall, but we also know that it's a pass-through. Dimensions are found in drawings. These are going to be a very important part of drawings. We need to know the size of something and we need to reference those dimensions. And referencing dimensions can be one of the most challenging things for someone that's learning print reading. I'm going to go through this in detail. We're going to start with we need to measure from point A to point B, not unlike we would do in the field. So we need to identify our 2 points we need to find that dimension for. Now we will always find a line that is parallel to that surface, wall, whatever it is we're trying to measure, and we're going to see a dimension line here. This dimension line will start and stop relative to that A and B point, exactly the same length. So that is our first part of our dimension line to define. That is the beginnings of our dimension. We're also going to have extension lines. These are going to connect us to our points A and B. They're short lines. Sometimes they could be longer, and we'll see why a little bit later. But now we started with our dimension lines. Now we have our extension lines. These are always 90 degrees to our dimension lines, and they are always going to touch the 2 points that we're interested in knowing the dimension of. So now we're going to see a measurement. We'll see a number very close to the dimension line. This number is going to be spelled out in a specific way that we can count on throughout the plans, and it should be an accurate number that we can also use. So what you might find is that this dimension, here it is breaking the dimension line. It's right there. It's very easy to find. Very often that dimension might not be on the line. It might be near it. In this case, it's above the line, and that's fairly standard. So here we have that dimension needs to be spelled out specifically. So it has to be a rule that we can follow and understand. And a universal rule for inches and feet is 1 tick or 2 ticks. So feet is always 1 tick. This will tell us the number of feet, and then 2 ticks will indicate the number of inches. So for example, we see here 1 foot 6 inches. So we can assume and always know that that means 1 foot 6 inches. You might see it spelled out FT or IN. All of these are typical standard ways to refer to or communicate dimensions. So now we're getting more complicated. We can look at one dimension, it makes sense, it's easy, but on plans there are multi-dimensions and they get very confusing. So now we have to talk about referencing accurately dimensions. And when you have multiple dimensions, it becomes harder. As you can see here, these 2 dimensions share a dimension line, but they're referencing 3 different points. So A to C is going to be this measurement, and C to B is going to be this measurement. They appear to be sharing this dimension line, but as you can see, there's an extension line in between them. And this happens to, based on these dimensions, cut this original dimension we were looking at from A to B exactly in half. I know this because these two dimensions are equal. So that tells me that this extension line is exactly in the middle of this measurement. So here we have 3 dimensions, and now we've added our original dimension, and now we're stacking these. This is where this starts to get confusing. So keep in mind that the numbers are very close to the dimension line that they are associated with. I've got 3 dimensions here, and this dimension is accessing this dimension line. One other thing to tell you is they're almost always going to be centered in the dimension line. So as you can see here, as I'm looking for this dimension, I can associate it with this dimension line, and now I'm looking at these 2 extension lines to verify that I'm looking at the right one. Indexing all of this is very important. What you don't want to do is to read the wrong dimension and think you're looking at the right one. Now you're making a mistake when you're building. So to make things even harder, we're looking at what an entire set of plans looks like. So here you see all of the dimensions in play. Everything in blue is our built structure, and all of these dimensions on the outside here are referencing or calling out specific places on this building. So as you can see, they really stack up quickly. So now you might understand a little more about why it's so important to carry a specific process through to index your dimensions. Look here we have stacked dimensions, and as we see here, any number we find, we're going to refer to that dimension line, then we're going to find the extension lines. And there's one thing I forgot to mention about a dimension that will help us to index when we're talking about our extension lines, and that's going to be the terminations for our extension lines. These are either hash marks or some type of universal symbol that's used. It could be an arrow, could be a hash mark, maybe a circle. There are several quote-unquote universal terminations for extension lines. These are there to help you to find that point where your dimension line meets your extension line. So if you're confused about where your dimension line stops and starts, you can always look for these terminations. Symbols are a whole nother element that we need to talk about. There's a lot of symbols in drawings, and symbols are something that's a simple icon to represent something else. So we talked about legends. They're full of our symbols, and you will find these symbols peppered all over your plans. I'm going to refer back to this electrical legend, and here you see called out a typical outlet, and it's placed on a wall where that outlet needs to be installed. So an electrician would look at this set of plans and know, based on this legend, that a typical duplex receptacle will be placed on this wall in this location, here and here. There are other symbols for other outlets or devices that will be put in for this electrician. He will follow all of these rules based on this legend and install these circuits based on this set of plans. Here are some more common symbols. There are symbols for everything in plans, and it could be something as simple as a window, and this is an understood symbol for a window. Every time you see this, you will know that's a window. Here is a door, and as you can see, a lot of the symbols have features on them that will they will sort of reference the object that they are trying to represent. So here we have a door, and as you see here, this is the arc of the door, and this is the door. So if you look at it no longer as a symbol, but as a door from above that opens and closes, it might make a little more sense. Here's a double door, and as you can see, we have 2 doors that swing in together. A set of stairs, if you think about it, this is a very simple, if you look at it from above, this would be a set of stairs, and it even shows a direction arrow that this is the direction down on that set of stairs. Could be that you have plumbing fixtures. This is a very simple icon for a toilet. Here we have a sink, a typical vanity sink, and this would be, if we looked at it from above, what a kitchen sink would look like in general terms. Even appliances can be spelled out with symbols. Here you have a refrigerator, and if you were to stand above your refrigerator, it looks very similar to this. Here is a dishwasher, and the dashed lines on this dishwasher symbol are indicating that this is a hidden part of the dishwasher. If you think about it, this dishwasher would only be visible from the front. So a lot of symbols carry logic in them that you can, if you don't know the symbol specifically, you can go to the legend or you can look at it and figure it out. This, as you could guess, would be a range, and sometimes this would double as an oven. And as you can see here, you see the burners on top. So everything about this symbol is helping us to understand what it is. Material symbols are also very common on a set of plans, and material symbols tend to be more patterns or wallpaper that get filled in spaces to help us when we're building understand what that material is that we need to build with at that specific location that we're building. So here you see a roof shingle, and on the plans this would be a front porch roof, and you can see here that is the material that's spelled out at this specific location on the plans. This would be a close-up of an elevation view of the plans. Here we have some other material symbols, and interestingly enough, our brick symbol looks very similar to our shingle symbol. So be careful, a lot of your symbols, we would not mistake bricks on a roof structure. So as we can see here, this was pulled from the same set of plans, very similar materials in the way they look, but make sure that you're not putting your asphalt shingles on your foundation or your bricks on your roof. So also other symbols, you might see cut ends of lumber would have an X at the ends. This is a very common symbol for earth or ground. So if we're showing fill dirt, this might be the symbol, and it would spread out for the entire area that we need to indicate that's where that material is. Concrete, this is a very universal symbol. As you can see here, you see small rocks or aggregate and sand, and this would cover whatever area, say a foundation poured of concrete. Insulation, this is a symbol that does not look like what the actual material is, and this is a very universal symbol. It shows a wavy line, and this would typically fill a wall symbol, or a section or a detail of a wall would be filled with this symbol to indicate insulation. There is a whole catalog of symbols, and it is good to just expose yourself to them, and with time they tend to start making more sense. There's no such thing as a universal book of symbols, but there are a lot of similarities in symbols. Check out, we have a resource of a whole list of symbols. It's a PDF, and make sure you review that to get started into this whole world of symbols. We also have symbols for orientation when we're looking at prints. And if you see a north arrow on prints, it's trying to indicate to you which direction is north. We need to know our north, south, east, west directions when we're building, because we have to place that building on a lot or a piece of land, and we have to get it pointed in the right direction. So according to this drawing right here, this is my north side. I'm looking at my north arrow. It's pointing to north. This side is north facing. Here's south, here's west, here's east. In this case, my north arrow is pointing up, which is more natural for us to look at and understand. If you don't see a north arrow, you can always assume that the drawing is oriented in such a way that north would be up. The fourth element for us to talk about in drawings are going to be notes. You are not going to be able to just draw lines, make dimensions, and draw in symbols. There's a ton of information that just can't be covered any other way than words. And notes are very abbreviated versions of words, and sometimes very specialized. So as you can see here, we're looking at a close-up of a simple note on a plan. And if you read it, if you take it at face value, it doesn't always make sense, but it's full of abbreviations and some very specific things that tell us how to build this foundation or garage floor slab. So what it says is 3,000 PSI, 4-inch concrete slab. So it's telling us that it's a 4-inch concrete slab that has to meet a certain strength. That's 3,000 pounds per square inch. This is a spec for concrete that's very common, and it's spelled out here specifically in the plans. It also says so it's saying inside of this concrete needs to have 6x6 WWM, which is welded wire mesh or fiber mesh reinforcement. So that's telling us that inside of that concrete, we have to put either this special steel mesh or some fiberglass fibers to reinforce it, to make it stronger. Then it's saying on top of a 6 mil polyvinyl butyrol over, which is basically plastic, over 4 inches minimum clean, well compacted fill. So the fill would be either dirt or gravel, or what specific type of fill is used there. Well compacted. And it also says the last thing, this is all mashed together, you have to sort it out. It says approved termite treatment process. So now I know as the builder, I need to treat the soil before I pour this slab. I need a well compacted fill to go on top of the existing soil on that lot. I then have to put sheet plastic down, 6 mil sheet plastic, and I need a reinforced 4-inch concrete slab that meets a minimum strength requirement of 3,000 psi. All of that spelled out in one note on this plan. So as you can see here, there's a lot of information included in a very small space. So notes are full of all of these abbreviations. This is where this idea of the language of building comes in. You might know English, but you don't necessarily know, in this case, here we see, these are general notes. This is a cover sheet version. These general notes they will apply to the entire building. So if we look at example number 3, it says all dimensions are from wall framing, from the face of the studs. So no finished dimensions are given. And it says UNO. So that would be unless noted otherwise. That's a way to abbreviate it. We're eliminating a lot of words. Now, whenever we see UNO, it's telling us something that doesn't need to be repeated, and it's not taking up space. This is a very important note for us to know about the building before we get started, because it's saying that all of the dimensions are pulled off rough framing. So this changes your building dimensions. This is a very common thing to do. When we're finishing out a structure, we're adding a lot of layers, and these layers will change the dimensions that we're measuring. So in this case, all of these dimensions are pulled off of the rough framing. Then we're going to add all of our finished materials later. Here are some detail notes. So details are going to us specifics about a building. In this case, we're looking at a foundation that's going to be poured. And this is a section. We've cut through a particular place on this foundation. We're looking at a wall sample that's sitting on top of that. Here is our slab, and here is a footing that the wall is sitting on top of. So there are a ton of material symbols in here. This is a section view, but look at all the notes. So the notes are spelling out things that we cannot know by just looking at the lines, at the dimensions, or the symbols. This is our 4th element that's really important. And there's generally arrows drawn to specific places on this section detail. And it says building wrap on top of 7/16 OSB. And then there's an abbreviation for sheeting, SHTG. So it's going to be full of widths, would be W with a slash. Anywhere we can save space and abbreviate, we tend to do that on a set of plans. So that concludes our 4 elements of prints. Make sure you continue into session 2. That's going to cover a lot more information about basic print reading. Thanks for watching. I'll see you in the next video. This video is a production of Trade Skills U, all rights reserved. If you provide instruction in the construction trades and have a need for videos like these, please contact us at tradeskillsu.com.